Alright, hey there, science students. In this video, we're going to be talking about metamorphic rocks and the rock cycle. So let's get to it. So, metamorphic rocks, these are rocks that are formed from pre-existing rocks, so rocks that already existed. We call them parent rocks. Those rocks are then recrystallized. This means that the minerals within the rocks are rearranged without true melting. So we're not talking about like what forms igneous rocks where the whole rock is melted into a liquid. We're talking about like, a little bit of melting, not a complete melting here. This is caused by intense heat and pressure. So taking a look at your Earth Science reference table, page 7, you'll see that there are two types of metamorphic rocks, foliated and non-foliated. So let's look at the foliated first. So in a foliated rock, the minerals are going to be aligned. They all tend to kind of go the same way. They're going to line up with each other. They can also have something called banding, which is where we have dark and light colored minerals that are alternating, kind of striped like a zebra. And these occur during regional metamorphism. So regional metamorphism is the type of metamorphism that occurs over a very large area. So here's some examples of some pictures of mineral alignment right here with this one right here, and then some banding. So you can see the alternating colors in this rock. All right, now non-foliated metamorphic rocks are a little bit different. They don't have very many distinguishing features, unlike the foliated ones where they had all the minerals lined up. And they occur with either contact or regional metamorphism. So we're going to talk about both of those in a minute. So I got some pictures of them here. Here we can see a quartzite, a marble, and a hornfels. So you can see they're all kind of uniform in their color. Now, what makes these different from each other is the mineral content of them. So what are they made out of is going to be the biggest difference between all of these rocks. So the texture is going to be the first thing we're looking for. So mineral alignment, like I said, is when all the minerals are going to be aligned. They're going to be going the same direction. It's going to kind of look like pages of a book. Banding is when those minerals are going to be so changed, they're actually going to separate out into different bands of color, right? You're going to alternate light and dark. So for the top part of this chart, for our foliated rocks, all of them are a result of regional metamorphism, right? So they are all going to be formed over large areas. Now, parent rock. So parent rock is going to be what rock was first formed and then subsequently changed, or then changed by heat and pressure. So we're going to start here with shale. Shale is the parent rock of the rock slate. So you can see on the chart, it's going to go to our daughter rock. It's going to go from one shale to slate. It's going to go over. Now, from this point on, the chart's going to change a little bit. We're going to start going down the chart and looking at the parent rock that's going to be the rock above it. So slate is then going to be changed into phyllite. Phyllite, if we add more heat and pressure to slate, it's going to change into phyllite. So heat and pressure increases means that the phyllite will then turn into the schist. And if more heat and pressure are added, then it's going to turn into the rock gneiss. So you can see as we go down this chart, we have our parent rock on top and the daughter rock on bottom, and you can see how they change as we go through the chart. Heat and pressure are going to be increasing, moving from the top of the chart down to the bottom. All right, notice how in this one for the non-foliated, that they can be both regional or contact, or both, depending on which rock we're looking at, for how they were formed. The next column, that one in blue right there, is going to give you information about what the parent rock was. Now, that's going to be the most important thing when looking at these rocks and trying to identify them, is what they were before. So, for example, anthracite coal used to be bituminous coal. That's on our sedimentary rock chart. Quartzite used to be sandstone. That rock is also on our sedimentary rock chart, and so is limestone and dolostone, which created marble. The metaconglomerate also on our conglomerate is on our sedimentary rock chart. So a conglomerate that's subjected to heat and pressure is going to become a metaconglomerate when all those different pebbles start to melt together. All right, let's look at regional metamorphism over contact. So regional metamorphism occurs over a large area. And the large areas of the rock are changed into metamorphic rock. It occurs during major geologic events, such as tectonic plates coming together, subduction, that sort of thing. Contact metamorphism is a little bit different. It occurs over a small area, and it's usually when lava or magma comes in contact with another rock. It kind of bakes it and changes it based on just that heat. So usually a rock like Hornfels doesn't need to be under a whole lot of pressure in order to change, just a whole lot. All right, so the rock cycle is the ongoing process of changing from one rock into another. So when you're looking at your chart, you're going to see that there are the three rock names, igneous, sedimentary, and metamorphic. And you're also going to see that there are a bunch of processes on there as well. So I'm going to go over the processes first. So solidification is the process of turning magma and cooling it and hardening it into an igneous rock. It could also be lava, not just magma, but anything that's cooling down and turning into igneous rock. Metamorphism is the process of a rock becoming a metamorphic rock due to intense heat and pressure, or maybe just heat in the case of contact metamorphism. Weathering and erosion. This is the breaking up of rock into smaller pieces. This is what's going to produce sediments. And then compaction and cementation is that process of creating a sedimentary rock where the rocks are pressed and cemented together. All right, so let's take a look at this chart real quick. So you can see that we've got our three types of rocks labeled on here. We've got igneous rock right here, sedimentary rock right here, and metamorphic rock right here. Now, there's also two, I guess we could call them ingredients on here too. There's sediments and magma. These are the things that some of these rocks are before they become rocks. And then in between, we have all of these different processes. So you can see how this rock cycle can continue over and over by looking at how these, pre-rocks get to becoming rocks. So let's start with an igneous rock. An igneous rock, you'll see solidification is what's pointing at igneous rock, because all igneous rocks are formed from the solidification of either lava or magma. It could be deep underground, it could be at the surface, but that is what forms all of our igneous rocks. And you can see melting is what's pointing towards magma. Magma is liquid rock. So melting has to occur first before we can get solidification into an igneous rock. Now sediments. All the arrows pointing towards sediments are saying weathering and erosion. Weathering and erosion. So remember, weathering is the breaking down of rock, and erosion is the moving of that rock to somewhere else. Those sediments are then deposited and buried, and due to that pressure, they become compacted, cemented, and turned into a sedimentary rock. Metamorphic rocks are formed by heat and pressure. Heat and or pressure, I suppose. So you can see that all of the different rocks are pointing towards metamorphic rocks. Even metamorphic rock has this line that goes up, goes to heat and pressure, and can become a metamorphic rock. Remember, rocks like slate are the parent rock of a rock like phyllite. So a metamorphic rock can become another type of metamorphic rock due to heat and pressure. So you can see it kind of looks like a web, because you can get pretty much anywhere on the chart just by following these around. So sedimentary rocks can be melted, turned into magma, and become an igneous rock. Metamorphic rocks can be melted, turned into magma, become an igneous rock. Igneous rocks can be weathered and eroded into sediments to become a sedimentary rock. So can metamorphic rocks, and so can other sedimentary rocks. So it's all kind of connected, and there's no real beginning or end. It all just kind of keeps flowing and recycling material around the earth. All right, so that does it for our geology unit, and I will see you next time.